Hi Year 12, welcome back to the channel for your next lesson. We're starting off with a flashback question from the 2016 HSC multiple choice. Pause the video and decide whether you're going for A, B, C, or D. Okay, so we've got a mobile phone plan that are charging rates of 54 cents per 30 seconds. And the crucial part is or part thereof. We spoke about this in class quite a while ago. We said or part thereof means that as soon as you go over the threshold of one completed block, is how we talked about it, you're going to be charged for another entire block. What that means is, for example, if you had a 31-second phone call, well, they're going to charge you 2 blocks, so they're going to charge you 54 cents twice. So no matter whether it's 31 seconds or if it's 60 seconds, you're still going to be charged for 2 blocks of a call, so you're going to pay the rate twice. So for 2 minutes and 15 seconds, that's going to be the same thing as 2 minutes and 30 seconds. It's going to be 5 blocks of 30 seconds, which means we are going to pay 54 cents 5 times. So we do 5 multiplied by $0.54, and we get 270. So if you said D, you were spot on. So well done. All right, for today's lesson, we are looking at what's called inverse variation. Now, in my experience, a lot of standard math students find this concept really, really challenging. So feel free to go slow with this one. If you're not getting it at first, do not worry, because most people don't, in my experience. But let's see how you go. So we're going to warm up today by sketching the graph of y equals 1 divided by x. So as always, when we're looking at something that we aren't quite sure what it's going to look like, the best way to figure it out is with a table of values. So once again, let's draw up a quick table of values, and we're going to put these numbers from -2 up to +2 into this equation. So we're going to do 1 divided by these numbers, and we're going to get our answers. If you want to pause the video and try by yourself first, I would recommend it. All right, so here are our answers. So when we do 1 divided by 1/2, we get 2. 1 divided by 1 is 1. 1 over 2 is going to be 1/2, or 0.5. We get the same thing, but negative on the other side. Now, what happens with the 0 is we do not get an answer, because when we do 1 divided by 0, you've probably heard me or another maths teacher say in the last 6 years that you cannot divide by 0. It doesn't make sense. So we don't get an answer for this value here. It means when the value of x is 0, which is in the middle, we aren't going to have a value for y. So we're going to sort of skip that part. All right, so what happens when we sketch these up? We're going to have 0.52 up here. We're going to have 1, 1 here, and then 2, 0.5 here. So we're going to have this shape that starts really, really tall, comes down, and then gets really short, but it never actually crosses either of the x or y axis. It's going to look like this. Okay, this shape is called a hyperbola. So that's what you get when you have a variable or an x on the bottom of a fraction. All right, so we have getting closer and closer to the y-axis, and then coming down, getting close to the x-axis. And we have the same shape reflected in this quadrant down here for the negative parts. Okay, so importantly, we do not cross the x-axis and we do not cross the y-axis. Because we cannot divide by 0 and we cannot divide 1 by a number and the answer be 0. Neither of those things are going to work. All right, so let's talk about variation. When we were studying linear relationships much earlier in the year, we talked about direct variation. That's when you have 2 variables where if you increase one of them, the other variable also increases. So a good example could be how fast you're driving and how much fuel you are consuming. Those of you with your P plates might already know that if you are driving faster, your car is working harder and you're going to use more fuel. So these 2 variables have a direct variation. So a direct variation equation looks like this. You've got 2 variables that are linked by some constant multiplier, which we usually call k until we figure out what that number is. Usually there'll be some information in the question for us to figure out what k is. But this relationship is going to look something like this line right here, okay? As one variable increases, the other variable also increases. It's a direct link. Now today we're looking at the flip side of this. We're looking at what's called inverse variation. That means if one of your variables increases, the other one is going to decrease. So an example of this could be cars on the road and then speed of traffic. If you have more cars on the road, the speed of the traffic will decrease because of congestion. So the equation for inverse variation is going to look something like this. We have a k and an x, but this time instead of multiplying, they are dividing. Okay, so this shape is going to look like the thing we just graphed, that hyperbola, where it was approaching the axes and never quite getting there. So if we graph this equation, it would look like this. This is the top half of the graph. We're not going to look at the bottom half today because the bottom half has negative numbers, which for the problems we're going to explore is not really going to make much sense. We're typically looking at positive numbers for these relationships. For example, we can't have a negative number of cars on the road, okay? So whenever you read a question and it says the two magic words, direct variation, or it says varying directly, you've got to think, I'm using this equation here. The question will not tell you the equation. That's got to be part of your content knowledge. And that's why these are usually high scoring, like band 4 or 5 questions, because if you don't study, you're going to find these really, really difficult. Likewise, when you see a question talking about inverse variation, or if they say they have an inverse relationship, you've got to think to yourself, I'm going to write down this equation and I'm going to use it, which is pretty tricky. So let's have a look at a couple of examples where we're going to make this equation and then figure out what the value of k is so we can answer some questions. All right, here's our first one. We have the number of trees that can be planted along the fence line of a paddock. That is varying inversely with the distance between each tree. All right, so as the distance between the trees increases, you've got less room, so the number of trees you can plant is going to decrease. All right, this is an inverse variation. Question says, when there's 108 trees, there's a 5-meter distance between them, okay? So first part of the question, find the equation which relates the number of trees to the distance between them. This is the really challenging part. This would be like I said, at least a band 4 or 5 question in HSC, because you've got to know the correct process. All right, so here is the process. When we read the magic numbers, varies inversely, we've got to write our inverse variation equation. Now on the last slide, we were using y's and x's. They were just placeholders. Normally we can use the letters from the question. So instead of y and x being our variables, this time we're going to use t for number of trees and d as the distance between them. Okay, these are two variables that have an inverse relationship. Now these two variables are going to be related by the number k, which we are going to figure out. Luckily, there is some information in the question for us to use this equation and figure out what the value of k is. So the question says, when there is 108 trees, so when t is going to be 108, it says the distance between them is 5 meters. So d for distance is going to be 5. All right, so we've written down our equation. We've subbed in some values from the question. Now we're going to solve for k. How do we solve this equation? We multiply the 5 across, or we're multiplying both sides by 5 to get rid of the divided by 5. 5 times 108 works out to be 540, and there you go. We have figured out what the value of k is. So now we can rewrite this equation. We're going to leave t as t and d as d because they're our variables. But now the k value is always going to be the same thing. It's always going to be 540. So we're going to write that. All right, that is the harder part done. Now we can use the equation to answer some questions. So the first question is, how many trees can be planted if the distance between them is 6 meters? All right, so how many trees? So find t, number of trees, when the distance, d, between them is 6 meters. So we're going to take our equation, we're going to make the value of d equal to 6, and we're going to see what the value of capital T is. Which is not super challenging. We've just got to do 540 divided by 6. So we get an answer of 90. So when there's a 6 meter gap between our trees, we can plant 90 trees. There's our answer. And now for part C, pretty similar. What is the distance between the trees if 120 are planted? Okay, so now we know that the number of trees, which we represent by capital T, that's going to be 120. We're going to use this equation and try and figure out what the value for distance is, because we're trying to find the distance between the trees. All right, we take our equation, we make the T value equal to 120. And now this one is a little bit trickier to solve. We solved equations like this when we were studying trigonometry and we were finding sides, and we were always saying to ourselves, we're either swapping or sliding. This is one of those questions where we would have been swapping, because what we're trying to find, what we're trying to solve, is on the bottom of the fraction. So we're going to put the D over on the left-hand side, and we're going to move the 120 down below. So these two values here are just going to swap places. So we have D equals 540 divided by 120. That works out to be about 4.5 exactly, actually. So when there are 120 trees, rearranging this formula by putting the D here and the 120 there, we get an answer of 4.5, and we've answered the question. All right, beautiful. Let's look at another one to get a bit more confident with this concept, because like I said, it's a really challenging concept. Okay, for this one, we have the time taken, which is going to be represented by capital T, which is number of years. Time taken to build a pyramid is inversely related to the number of slaves you have available, which we're going to represent by N. Okay, we know that if we have 400 slaves, it takes a decade to build a pyramid. How many slaves will be needed to complete the build in 3 years? I'd just like to get on the record that Mathematics as a channel does not support slavery. This is just a historically themed mathematical question. All right, cool. So how are we going to approach this? Well, the two important words we need to focus on are right here, inversely related. Okay, that means as one variable increases, the other variable decreases, which makes sense because if you increase the number of slaves you have available, the time taken to build your pyramid is going to reduce because you've got more people to work on it. So mathematically, we need to write this as an equation, which looks like this. Okay, this is capital T and lowercase n having an inverse relationship. As n increases, T decreases. Okay, now just like last example, we've got to figure out the value of K by using the values in the question. So we know that when we have 400 slaves, so when N is 400, it takes us a decade to build the pyramid. So T for number of years is going to be 10. So we're going to substitute in those values. So T equals 10, N equals 400. We're now going to solve this equation for K by multiplying the 400 across. So we get K is equal to 400 times 10. So we have K is equal to 4,000. And now we're on our way. We know what the value of K is, so we can write it up top here. And now we can use this equation to answer the question. All right, so the question is, how many slaves will we need? So we're trying to find N if the time taken to complete the build, which is T, is going to be 3 years. So we're going to make capital T equal to 3. Now we're going to solve this one similar to the way we did example C in the last slide. We're going to move the N across and then divide the 3 underneath. So these two pieces are going to swap places. We're going to have N equals 4,000 divided by 3, which is going to be about 1,333, and then 3 is going forever. Now we don't want to leave our answer like this because we can't have a third of a slave, thankfully. So I want you to think, what would be a better answer? 1,333 or 1,334? Well, the question asked how many volunteers do we need to complete the build in 3 years? If we had 1,333, it'd be slightly too many. We'd be off by a third of a slave. So to complete the build in 3 years, we need to round up for this question. So we're going to say 1,334 unpaid volunteer workers. All right, beautiful. So the important part that the skill we need to focus on today is turning that first sentence into a mathematical equation. That is the tricky part. Once you can get this down and find your value of K, these questions always follow the same formula. And to prove that to you, here is an HSC question to finish off from 2010. Anytime there is an inverse variation question, like I said, it's going to be a high band question because they're really challenging. All right, we have the number of hours it takes for a block of ice to melt varies inversely with the temperature, which makes sense. If the temperature goes up, the block is going to melt quicker, so the other variable, which is time, is going to go down. Okay, 30 degrees, it takes 8 hours for the block to melt. How long will it take the same size block of ice to melt if it was instead 12 degrees? All right, go ahead and pause the video and see if you can figure out this one for yourself, and then I'll spoil it for you very shortly. So varies inversely tells us we're going to have an inverse variation equation. Let's get some variables. I'm just going to call number of hours capital H, and I'm going to call temperature capital T. Now, if these two variables are inversely related, I can write them up as an equation like this: H equals K divided by T. I just want to say right now, if you swap these two and you had T equals K over H, that's technically the same thing and we're going to get the same answer. So don't worry about which variable is where. As long as the K is up here, you're going to be all sweet. All right, now 30 degrees is going to be temperature, which is T, and 8 is going to be hours, H, and we can figure out what K is. All right, we're going to multiply the 30 across. So we're going to get K equals 30 times 8. So we get 240. Now we'll make the value of K 240, and we can use this equation to answer the question. Question was, how long will it take? So find hours to melt the block if temperature T is 12 degrees. So we're going to make T equal to 12, and we're going to do 240 divided by 12. And so awesome work. If you got 20 as your answer, you are spot on. So like I said, the scary part is going from that first sentence to this equation and then finding K. That's the part that you guys need to practice so you can be prepared for questions like this, because they are pretty common HSC questions. You see them every 2 or 3 years typically. All right, that'll do it for today's video. Here are some practice questions from your textbook to give you some more confidence with these concepts, and then I'll see you for the next lesson in a couple of days. Thanks so much if you made it this far. I'll see you next time. Ciao.